Have is a body of mass 7m lies in a smooth horizontal table. So this one, as it turns out, there's no friction at the moment. This one, so it's smooth. It is connected by means of light inextensible string passing over a smooth light pulley at the edge of the table. A second smooth pulley of 5m, so you're talking about your 5mg here going directly down, is connected, and you have a 2mg here, guys, and then a 3mg going down here. So we have a lot of weight. So if we add that quickly together, you're looking at a 10 versus 7. So it's going to move. Okay. So we have a common acceleration A. So the common acceleration is shared between the 7 and the 5m pulley. Then we need a secondary acceleration. We'll call it a B. Now it's going to be the 2m mass is going to be going up, while on its way down will be the 3mg mass. Okay, so guys, showing separate diagrams, the forces act on each mass and the pulley show that the acceleration of the 7m mass is 7/12. So what that's basically telling me is that I don't really need to find out B, I need to find out A, but we might need to find B to find A, we don't know yet. Okay, so goal of question, what is A? Okay, so let's do our diagrams. So we start off with the 7m. So 7m has a reaction force R. Not going to use R because of we'd only use it for friction. There's no friction here. Then we got a tension pulling it to the right, and no friction opposing its motion. Okay, so that's the 7m particle right there. So what we're going to do next then is we're going to look at the 5m particle on its own. So the 5m particle, something like this. Okay, and it has its 2 on the way down. So this one here, there's 2 tensions because there's 2 different strings. So we'll label that T1 actually. The last one could be T1. So we're going to have is a T1 going upwards, and we're going to have a T2 pulling it directly down. Anything I left out? So your 5mg, your weight, that has to go through here as well. So tension up, 2 tensions down, and its weight forcing it downwards. Okay. Then we're going to go to the 2m. So the 2m is reasonably easy. So what we have here is 2mg. 2mg going down. On its way up is T2. And we said that this one is up with acceleration B. And then the last one, T2, and now it's 3mg going down. And this is going down with an acceleration of B. Now, one thing there, the B is relative. So can anybody tell me the acceleration of the 3m particle? The acceleration of the 3m particle? It's going to be A plus B, because it's going B downwards, but it's already traveling on an object that's moving already. So the 3m is an A plus B, and the 2m particle, what do you think it's going to be? The acceleration of the 2m particle? It's either A minus B or B minus A. Depends on what you think is going to happen. So if we say A minus B, that means we're saying that it's overall it's going to be going downwards, not upwards. Okay, B minus A would mean upwards. Okay, and then the maths will correct itself if you made that assumption wrong. Now let's begin by making some formulas. Okay, so we'll start off with the ones we can see. So they're all F equal to ma. We'll start off with the 2m mass. So what do you think about the 2m mass, guys? What formula should this be? Okay. Okay, so 2 mg going directly down. T2 minus 2 mg would imply it's going up. But remember we said that it's A minus B. Well, in isolation you're right, B has to go up. But overall we're saying that it might go down, because remember we said that it's on a moving acceleration. So either way you get the same answer. I'll do it both ways, right, just to clarify, okay? So you can do it two ways, right? The way I'd do it is I'd say 2 mg minus T2. I have the downward in front of the upward, okay? So I'm thinking that down is the way to go. Then 2m is your mass, and then what's the acceleration? A minus b. Now, if I went with your system, I'd do T2 minus 2 mg, and because T2 is going upwards, means the system should go upwards, which means instead of B minus A, or sorry, A minus B, I'd have B minus A. And you can see that it's basically the equivalent of multiplying both sides by minus 1. It's basically, so you get the same answer. Okay? So that's cool there. And now we're on to, that's the 2 mg mass. We'll just multiply it out, and we get 2 mg minus T2 equals 2 ma minus 2 mb. Okay, so that's that one there, and dusted. Okay, guys. So what about the next one, guys? We're going to look at this one here. So the 3m mass. So we know it's going down at A plus B. So we're going to get our 3 mg going downwards. We have our T2 pulling in the opposite direction, supporting it upwards. And then we're going to have 3m is the mass of the object, so we're underneath the m part. And then we have to figure out its acceleration being A plus B. And then we're going to get 3 mg minus T2 equals 3 ma plus 3 mb. Alright? So that's the second equation. Okay. Now that I've basically used up the two of them, I can come up here and drag the two of these diagrams down, because I need them. So this is what I'm looking at next. So okay, so that's those two formulas there. Now this formula here, we'll start off as the pulley. How much does pulley weigh again? The 5m pulley, is it? The 5m pulley. So once again we're going with F equals ma, as always. What forces are on the pulley, and what way is the pulley going? It's going down with an acceleration of A. Okay, so what's happening? What are the forces at play, guys? So it's going downwards, so pick a downward force to start off with. 5 mg. Any other downward forces to complement it? 2 T2s. Something to take away from that downward force? Minus T1. And then finally equals 5 ma. Because it's your mass times your acceleration. Okay, so that's another equation. So we're up to 3, and we only have the fourth one left. So we'll bring that down there. Now, the fourth one is for the 7m mass. Okay, so what can we say about the 7m mass, guys? I think it's a pretty easy one actually, isn't it? F equals ma. It's definitely going to the right. So and the only force pulling it is the tension. So T1 Oh, sorry, just T, is it? No, T1. T1 equals 7MA. So that's pretty easy. That's a good substitute for T1 there. Now, let's circle what we need. So, momento. So I need this formula here. So this formula here goes down that one there, and then no idea what happened there, and that one there, and that one in the red one in the corner. So I'm just going to label them. So this is the first formula. It's the 2M one. That appears to be the 5M pulley. This one here is the 3M, and finally this is the 7M. So we have all four equations ready to go. So yeah. Okay guys, so we're just going to look at these 7 equations and decide where to start off with. So just label them A, B, C and all that. So A, B, C, D. Okay. We're looking for the acceleration A. Get rid of your tensions as soon as you can. One of them's already done for me. The 7MA is already done. And so I have to get T2 on its own. So I'm going to use equation C or equation A to get T2 on its own. In fact, I'll do it to both of them. So let's start off. Bring T2 to the left and T2 to the right and everything else to the left. So equation C will become T2 equal to 3mg minus 3ma minus 3mb. That's still equation B. Okay, using equation A, T2 to the right, everything else to the left. T2 ends up to be 2mg minus 2ma plus 2mb. And that is coming from equation A. Now, I'm going to put these two equations equal to each other, and then I'm going to form a simultaneous equation containing only A and B. So we're going to have 3mg minus 3ma minus 3mb equals 2mg minus 2ma plus 2mb. Bring everything over one side. Okay. The m's will cancel. Okay. I'm going to have minus 3a and minus 3a. Then we're going to bring over the 2a. It becomes plus 2a, so this is going to be minus 1a. The minus 3b is going to be joined by minus 2b to become minus 5b. And finally, this 2g here is going to be joined by a minus 3g. And the 2g minus 3g gives you minus g. I'm going to multiply both sides by minus 1. And tidy that up. Everybody have enough of that? Okie dokes. Gotta go back up to the top again. And I'm going to have to substitute. I'm going to grab this formula here. The one that has the T1 and the T2 in it. Oh dear. Wait 1 second. So this formula here is the one I need. So bring this one down. What's the other one? T1 equals 7ma. Okay, we can handle that as well. And T1 equals 7ma. I'll bring you down here. So what I'm going to do with this formula is the 5mg stays where it is. No bother. Tick 2T2. Pick either one of the T2s you have on its own. Doesn't matter if it's the first one or the second one, it really doesn't matter. And just multiply them by 2. I'm going to go for the second one. Don't know why, I just like the idea of multiplying 2 by 2. So multiply that, you get 4mg 2 by minus 2ma gives you minus 4ma. 2 by 2mb gives you plus 4mb. Minus t1 minus 7ma, and the whole thing equals 5ma. Now, like last time, what I might do is just do an extra line. 9mg, bring the 5m over to your side, it's going to be minus 9ma. And, whoa, I also forgot the other ma. So, bring the 5 over, it's minus 9ma, but then there's a minus 7 there as well, so it's minus 16ma. And then, how many mbs do we have? Just 4mb, equal to 0. Move everything over to one side, minus 16a plus 4b, and just striking off all the m's here. Minus 16a plus 4b equals minus 9mg. Okay. So here's our simultaneous equation. Now, what were we trying to get rid of? Which one are we trying to find? We're trying to find A, right? So it makes sense from a time management point of view is that we just get rid of the b's right away. So multiply the top one by minus 5, multiply by minus 5, and the bottom one by 4. See what happens. 88 minus 20b equals 45mg. Is that right? And then 4a plus 20b. Oh, there's no m. See the m? Should have cancelled that. So it's actually just 9g. It got cancelled over here. So 45g. And then what is this? 4g here. 84a equals 49g. A equals 49 over 84g.